All right. Good evening, everyone. Thank you for making out time to join in, and then we'll get started um, very shortly. So, as you can see from the flyer on display, it says beyond the code, a day in the life of a machine learning engineer. All right. So, basically, what today's session is all about is as you have seen also from the content that have been put out, for those of us that have seen it, it's more of a round of event for our recently completed Oktoberfest MLAI Open Source Challenge. So I don't know if we have some of the people that participated in that challenge currently on the call, right? So we're going to do a run through or a summary of how the challenge went, talk about the projects that have been deployed, and then we'll have an amazing session with Aleksandr. He's going to walk us through semi-supervised learning and give us an insight into what it means or a day in his life as a machine learning engineer at Meta UK. So I'm Samuel Bangbola, a Better Microsoft Learning Student Ambassador from University of Lagos. And we have Aleksandr, who we already introduced as a machine learning engineer at Meta UK. Right. So just after I speak a little on the challenge, he will go on to talk to us, and then as the topic says, a day in the life of machine learning engineer, we have I'm pretty sure many of us have questions on your roles or what the role means to you or what you want the role to mean to you in any way. So you have different questions on maybe getting a job, getting started, what is important skill to have to be employable, and so many other things like that, right? So Aleksandr will be taking us all through that and is willing to answer all our questions as much as possible, I believe. So let's go into the main talk or the first talk for today. So like I mentioned, this event is more like a summary or a catch-up or round-off of the Oktoberfest challenge. And I believe many of us were part of this challenge in one way or the other, right? So I'm sure we have a few contributors. I mean, many of us that were contributors to this particular challenge probably already seen this call, right? The design, or let me say the publicity for this particular call. So I'm just going to walk through us of how the challenge went. So basically, like I already said, a machine learning AI challenge. And the reason why we actually even created this challenge is because we observed, right, myself and other Microsoft Learning Student ambassadors in Nigeria observed that there's not so much open source materials or open source, let me say, projects or repositories to contribute to as a data scientist or as a machine learning engineer or as an AI engineer. So we actually set up this particular repository to be beginner friendly and to help everyone that has an interest in machine learning or AI to get started with open source, right? So we had 3 different projects. The first one was on building classification, so an image classification project of different building types. And then we had so many contributors working on that using convolutional neural networks, some using efficient BS, and the likes of it, different models, transfer learning, ResNet. So many people applied different approaches to actually solve this problem, and then we got some of the best rewarded some of the best contributors. The second project was a speech translation project, right? Leveraging Microsoft Azure Speech Service and then the translator service. So a speech translator project from English to Yoruba, Igbo, or Hausa, right, which are local languages in Nigeria. So let me show you a demo of this application here, right? We actually deployed this. This is one of out of the three projects. This is the only one that has been deployed yet. So we're still working towards deploying the the image classification project. So you can test it out. Maybe you want to translate an audio file to Yoruba. I have a sample audio file here, which I'm just going to load in, and it's basically an introduction made by a teacher that is new to a class or new to his new students. So in English, it basically says, "Hi, students, I'll be your teacher for this year," and the rest. So you can see that it's being translated there. For those who understand the Yoruba, what it says is, "Ẹnlẹ́ ẹ̀yin akẹ́kọ̀ọ́, èmi yóò jẹ́ olùkọ́ yín fún ọdún yìí," and the rest of it. Orúkọ mi ni Microsoft. Ó sì dára láti mọ gbogbo yín. Basically, a welcome address made by a teacher, right? So this solution can be applied to different places, schools, regions with language barriers, and that was the major reason why we actually chose this project to introduce people to work with Azure AI services to build whatever solutions they would like to build. Just before I go on, am I audible enough? Can everyone hear me?
Yes, you're audible enough.
All right, thank you very much. Okay, so you can also try to do a translation in text. So let me say I'm trying to translate to Igbo and say, "Hi guys, thanks for joining this session." Right? I mean, I'm not a Yoruba person, but I think whatever this might mean to you, you probably understand. For those that can read Igbo language, same thing. If you want to do a translation to Hausa, you can also do that too. So that was the goal of this particular project, and we're happy that we're able to deploy it. So moving on to the last projects that we worked on was the prediction, the one GPA prediction of Nigerian students. So we had different features in that particular data set: JAM score, YS score, your reading patterns, maybe your health issues and everything. And then we worked on that. And then we got a model, right? We got a very good model from Awojide Tola, but we can't deploy this solution here because we were not able to collect enough data, right? So we're still working towards, sharing out the survey that was curated for this particular project, fill it up, populate it more from different people so that we can build a more robust solution, right? So the project was all about, like I already said, predicting the CGPA of the year one CGPA of a Nigerian student. And the idea around it was that for freshers coming into school, maybe they have, maybe for after first 2-3 weeks, okay, they've kind of observed, okay, this is how I like to read, and then maybe this is how much I have with me, how buoyant you are financially, and different things. Of course, you have your JAM score and YS score already and everything. So you can use this particular solution to project your performance in school for that next 1 year you are in, and you can see, okay, with this current route that you're going, you're expecting very good results at the end or not. So you can know that you need to probably re-strategize or something, right? So this is the summary of the whole challenge. We had top contributors, and we rewarded them accordingly with vouchers to take any fundamental exam, Microsoft fundamental exam of their choice, including the Azure AI 900. And we currently have an ongoing study group to help members be part of that, and then prepare them for the exam fully. Others have also indicated interest and joined in too. So weekly contributors also got prizes of LinkedIn vouchers, right, as a reward, yeah, for their contribution. So this is what the leaderboard currently looks like. And then so just before I round up and then head over, let Aleksandr introduce himself and get started with him. I just want to show us a quick report of the challenge. So for few of us that probably might have not been part of the challenge, or for those that are actually part of the challenge and just want to see how everything went in more details, right? So we had over 93 people visit the repository, right? So this is just the minimum, how GitHub tracks everything weekly. So I mean monthly, you can only go back by a month, but we had over 93 people, unique visitors to that repository, a total of 748 commits on the repository by different contributors, right? We had 92 merged pull requests from all the contributors on the repository, right? And these numbers are very, very, very impressive and amazing, right? 67 forks on the repository, 35 stars, and then all contributors, total contributors that were active, that had pull requests merged, are 34 in number. So and the main, like I mentioned, the main initiative why we actually created this to help people get started in open source, right? We had 41% of the total contributions, or the total contributors from the 34, right, making their first GitHub pull request through this challenge and having them merged also. So I think we got to the right people, and the people that the main goal of the challenge, right, was actually met through these numbers that you can see from here for data scientists and machine learning engineers as a whole. We had 3 projects which already run us through. We have 4 design contributors. I believe maybe a few of them might be on the call currently, right? So all the designs that you saw during the challenge, including these reports that you are seeing, were curated by 4 amazing contributors, right? We had 12 issues that were created during this challenge, and all of them were either fully or partially solved. We had contributors from 3 different countries: Nigeria, Portugal, and India. So it was the project actually went far in terms of across the nation. So we're happy that even others outside Nigeria were able to actually find this project interesting and be able to contribute to it. So this is a quick run through of how the challenge went, and I would also like to congratulate all those that were active during this challenge, that participated, that won the prizes and all that. And then this is, like I already said, a round-off event of that. And then congratulations to all those that contributed to this project. And then we hope to see you do more amazing things beyond this project. And just to point out, this project, if you're as an actual contributor, can actually be included, right, in your resume. So if you worked on either of any of the project, or for example, the speech translator project that have been deployed, you can include this in your resume as a project that you worked on, probably worked on an open source project to build a speech translator service. However you want to include it, you can include the link. I mean, the GitHub repository shows that you are a contributor, so it's not like you're framing anything. So open source contributions can actually be included in your resume, right? So it's something that you should be really proud of for those that were able to contribute to this repository among ambassadors, students, and other professionals in the field. So that'll be it from me. And just before I stop sharing my screen, I just want to point out that if you're a student, right, and you want to get started with learning how to use Microsoft Azure, Microsoft has a plan you can activate. If you have not already done so, you'll have access to $100 Azure credits for free, and it's renewable each year as long as you're still a student. So you can explore different Azure AI services. If you have some, like, this call is basically centered around AI, right? You can explore Azure AI services, Azure Open AI services, the translator, the speech service, and so many of them, like that, document intelligence, Azure Cognitive Search for creating search, advanced search solutions, and so many other things, right? This is a plan that you'd like to leverage. And if you have interest in maybe cloud as a whole, DevOps, Azure is also a very good cloud service you can get started with as a student due to the credits that you have. So thank you very much for joining in this call. Aleksandr, over to you.
Okay, can you hear me now?
Yes, I can.
Okay, sounds great. Let me share my screen first. Okay, so I was invited to talk a bit about some of the interesting topics, and after that to answer on your questions. So please don't hesitate to ask anything. And since we have a bit more than 1 hour, I'll try to be a bit faster. So if you have any questions, don't hesitate to interrupt me. Okay. So I'll talk a bit about semi-supervised learning. First, I will try to give brief overview of the idea. After that, we'll show some Jupyter Notebook, how we can try to build, to implement this approach. And after that, we will talk a bit about machine learning engineer job in general. Okay. First, a bit about me. I was born in a small city in Russia, around like 40,000 people. Just show for you to have some relation like to Nigerian cities. I don't know exactly how big is it or how small it is, but I feel my feelings as well, even for Nigeria, like small as well. So, and from my school, I loved mathematics, and in my mind, it is the most important thing in relation to machine learning later. So a bit about work. Now I work at Meta in London on malware detection. At the same time, now I am waiting for visa to the United States. So when I receive it, I will move to Menlo Park, California, to headquarters. Before I joined Meta, I spent almost 3 years in Petronas, Malaysia. Petronas is the largest oil and gas company in Malaysia. When I joined the team, I found computer vision projects the most interesting, and that time it wasn't well developed yet. So I started building a team. I started talking with guys, and from the beginning, we developed different projects related to inspections, more precisely corrosion detection, cracks, etc. Security, which included face mask detection and other things. And before that, I worked in finance and a bit more in e-commerce. A part of my work, I like still learning. I mentioned I love mathematics, so I take some graduate courses at Stanford. And besides this, I like to have rest. I like to travel, dive, and other things. So, okay, what we are going to talk today. I will remind what kind of machine learning algorithms exist. After that, I did highlight what is the difference between discriminative learning and generative models. I will highlight again what is classification pipeline. After that, I will talk a bit about Gen AI models, more precisely about variational autoencoder overview. And finally, this introduction will bring us to semi-supervised learning. Why actually it was important to talk a bit about classification and a bit variational autoencoders. Okay, let's move on. First of all, when you just go to any search, Google, whatever, and ask like, what kind of machine learning algorithms exist, majority of you will find like supervised learning, unsupervised learning, and reinforcement learning. I'm not going to talk about reinforcement learning at all, but a bit we are going to talk about supervised learning and unsupervised learning. And if we move one more step forward, we will find some mixes, etc. Many of you, I assume, might hear about self-supervised learning, when in fact we don't have labels, but we create them. For instance, for natural language processing, we have a text, and the next word is a natural label. We didn't have them. We did not collect them, but we had it naturally. So we have generative modeling, semi-supervised learning, where we actually combine ideas from supervised learning and generative learning. Okay, now a bit more. What is discriminative learning? What is generative learning? I put here two animals. One is capybara, is from Brazil, where I'm now, and one is eagle, as I understand, is kind of your animal in Nigeria. Sorry, your bird in Nigeria. Okay, what is discriminative learning? When we need to classify something. For instance, we have image, and we have to build some model that give us the answer. What is this? Is it capybara or it's the eagle? And from the probability theory of view, we need to build some build some model that predict probability of y with condition of x. X is our image, y is the class prediction. Generative modeling is quite opposite. We should build some density function that describe our space. So if we have labels, for instance, y is capybara, we need to generate some image that will look that it's capybara, but not like dog, whatever. If we have label that it's eagle, we need to see that it's eagle, but not some weird chicken. So we don't have image. Image is not given to us. Our goal is to build joint probability over x and y, over images and labels. Okay, now let's recall back what is classification pipeline, like how we build classification models. When we are talking about almost any classification, when we need to classify something, we need to have few things. We need to have data, and what is important, we need to have labeled data. We need to have some model, in fact, like some function, like Samuel talked before, you can use convolutional layers, you can use any types of layers. So we take data, we send it to our model calculate something, and give you some information, some result. So in fact, model is a function. And after that, when we have some output from model, we need to compare these outputs with our labels and calculate loss function. So loss is another function that tells us how good or how bad is our prediction. Okay, when we have this result about how well is our model works, we apply some of algorithm for gradient descent. There are many of them you can explore. and repeat this process many times. But as some of you who worked in production, you might have you might experience problem of labels. Like not everywhere you can have them. In finance, it's pretty easy. Like person take apply for credit card, and after that person either return money or don't return money. So it's natural labels. But there are situations where it's not that easy to collect them. For instance, there are two examples. First example, I worked with corrosion detection. To collect big data set of labels, you need to spend a lot of time. You need to spend a lot of money for labelers who will do them. Another example, I don't know, malware detection. It's not that easy to collect data of malicious extensions. Malicious extensions, I think all of you know about this, but if not, the idea is pretty simple. So you have software that do something bad for your computer. For instance, steal your credentials or infect your computer, etc., etc. So what we can do if we don't have enough labels? Let's remember this question and talk about second part of this story about generative models. In general, what is generative model, like super famous word now, GNAI, etc. We need to find some function to build some model, complicated model that will model our probability density function. We have a lot of images as usual, but we don't have exact function that can tell us that, okay, this image from this particular distribution. What can we do? We can try to model this function. And we have some requirement for this model function. First of all, let's imagine we build this function, we build this model, and we try to sample from this model. If we sample it, we should look at this image, and this image should look like close to capybara if we created this model based on images of capybara. Besides this, we need to know, like, okay, we label, we just take image of capybara, and let's try to find, like, let's try to calculate our density estimation. We should expect that density of probability density of this image will be high if it looks like capybara. But, like, I don't know, if it looks like bottle, it should be not that high. And another requirement, unsupervised learning representation, if we build our function and extract some intermediate layers, this representation embedding should look should be close for similar images and not close for different images. Okay. So we have to have some distance between these distributions, between these models, one of them that we modeled and another one that exists, but we don't know about this. Okay. What kind of types of generative models exist? As usual, people talk about two different types. First one with explicit modeling of density function, and another one with implicit modeling. Implicit modeling when we in fact don't care too much about density function. We care much more about just quality of the images. And it's pretty common, pretty famous approach, generative adversarial networks, when in fact we just build model that that will generate beautiful images, but we don't know in fact what is the density estimation. Another approach where we actually care somehow not only about quality of the images, but as well about value of our probability density function. And there are many different approaches. Later you can explore some of them. You can, sorry, ask me later offline some more links I will share with you. But overall, I think some of you who explore generative modeling heard about score-based models, diffusion models, which is the same as score-based models. Stable diffusion was one of the most popular. Besides these autoregressive models, when you just predict next element based on previous one, energy-based models, and latent variable models, which is represented by variational autoencoder. And I will talk a bit about this. Any questions at the moment, or I can move on? Okay.
I don't have any questions.
Okay. Sorry?
Yeah, I was saying I don't have any questions that you can go on.
Okay. Okay, sure. Let's move on. What is variational autoencoder? Main idea again. What if we try to model this approach that we take, like we have again data set of many images. You can talk about text, you can talk about audio. Idea will be the same, just approach slightly different in architectures. Like let's imagine we have the image. Let's try to build model that contains in fact two parts. First part is encoder and second part is decoder. What is encoder doing? Encoder takes this image and produce output with smaller dimension that somehow represent this image, or somehow represent dependencies in this image. And after that, we take this representation, which has like less dimensions, and send it to decoder, which should in fact output our input image or like close image. Why we are doing this? We want again to build some representations and later remove our encoder and use only decoder to generate new images with similar distributions, which looks kind of similar. How we are going to do this? Let's go back a bit and let's remember the idea that I mentioned before for classification pipeline, which is in fact on a high level kind of similar. We have our images, we have our model, and we have our loss function. For classification case, we have our labels. But for our case, we have our data, it's our images. We have again our model, and we have our loss function. I wrote, in fact, not loss function, negative loss function, but for the idea, it doesn't matter. So what we want a few things. If you take a look at this formula, again, some of you might not know what is KL divergence, but it's pretty simple thing. The idea is like this: we just compare probability distributions of two distributions. One of them is hidden layer like PZ, and another one PZ given X. Sorry, not PZ, QZ given X. So closer distribution, smaller this value. And another one, reconstruction loss, which actually responsible for generation. So generated image should be similar with image which we send for like input. That's again the main idea. There are much more details, but again, I will share if you want later some links so you can explore when you have more time. And finally, we are coming to the main idea of our talk. So I decided just to ask ChatGPT what ChatGPT talk about semi-supervised learning. So semi-supervised learning is just machine learning approach. As I said, it combines a small amount of labeled data with large amount of unlabeled data. But in fact, small amount of labeled data responsible for classification approach, and large amount of unlabeled data responsible for generative approach, which is, as I said, coming back, responsible for this part, unsupervised learning representation. Similar images have close representation. Okay. That's the idea. Now, let me try to show you, before we move to like general conversation Q&A, let me share with you Jupyter Notebook to okay. Can you see my screen now? Another one. Yes. Okay. Great. I tried. I understand that topic considerably complicated, but I tried to make again a high-level idea and try to show you how you can apply this idea with Jupyter Notebook. So what we are doing, we again create some model that I mentioned before. Like anytime when you are modeling when you are doing machine learning, you need to have model. I created three things. First of all, encoder that takes as an input some image X and labels Y in this case. I built, here you can see some architecture. By the way, I use PyTorch. I hope it is more or less straightforward, but again, for those who use, I don't know, TensorFlow, JAX, etc., the idea more or less is the same. So we built some different layer, stuck them together, and sent to modeling. So for just encoder, I have some super simple layers, like linear layer, activation layer, linear, activation, linear. I apply network, and after that calculate parameters parameters of distribution that I receive exactly after encoder. In fact, it's just normal distribution Gaussian. After that, I just built a simple decoder with some different like architecture. And I built as well super simple classifier, again, just for the sake of idea. And to test this approach that I described, I just want to use MNIST dataset of images of 10 different numbers. If you are not familiar with this dataset, you can just have it here. But I think everyone more or less no. So that looks like this. Okay. what we are going to do, first of all, always when we build some model, I try to test if dimensions are right, so later not to spend too much time for debugging. I just create some random tensor with dimensions batch size and 784. 784, in fact, is just flattened 28 multiplied by 28, which is dimension of NIST data set. I create my classifier, which takes as an input output dimension. Output dimension is how many classes I have in this case. And as expected, I have output of 15, which was batch size, and 10, which is number of classes. Does it make sense at the moment regarding classifier? Okay, then since you are silent, I will continue. I test as well dimensions of encoder-decoder. And after that, we are moving towards creating a class for semi-supervised variational autoencoder. I already created model architectures for classifier, encoder, decoder, so I can reuse them. What I need to create mostly loss functions. And as I mentioned before, the idea is I combine classification loss function and generative loss function. That's the final loss function. So you can see here loss, generative weight multiplied by negative elbow, which is exactly generative loss function, plus classification loss multiplied by classification loss function, which is in fact cross entropy. Okay. Now in here, I calculate my generative loss function based on that formulas that I presented before in slides, slightly modified since we are talking about classification part. But again, you can ask me later some specific details. I leave my contacts and we can discuss later already, like offline. I create a training loop, which is absolutely similar with anything that you used before in your image translation, text translation tasks, etc. So just calculate loss function. It's just some preparation for this loss function. After that, I just send like backward loss function and make optimizer step. Optimizer, I forgot to say that before, I zero gradients, so make calculations. And after that, when everything is ready, we can just see what is our parameter, what is our metric, sorry. First, I train a pure classifier when I have weights for generative models 0 and for classifier 100. So just simply classifier, in fact. And if you look back, when I calculate loss function, so I just have this condition here. If generative weight more than 0, then I calculate my loss function. Otherwise, I just assign it 0, so it does not count at all. And in this case, when I calculate classification, I just send 10,000 steps, if I'm not mistaken. One moment, yes. No, 30,000 steps. And I see that final result for me, when I have not a lot of labels, for test accuracy is 76%. For 10 classes, it's not bad, in fact, but again, we always remember that it's this data set, just idea. Second, what I try, I just use another way. I just give more importance for generative part of the loss. So I just take it 1. Classification weight is still 100. And I train model. I see output, blah, blah, blah. And what I see for test accuracy is more than 90%. So what we can see, we see that even though we don't have enough labels, like in fact 100, if I'm not mistaken, I can use another part of the loss that actually explore images. So you can use, you can try the same approach for text. I'm going to do it in fact later when I have time. And your model during training will explore dependencies in your data and use them to later predict, to make better prediction. So that's the main idea that I wanted to talk today. Before we move to more like general discussion, before we move to more general discussion about machine learning engineering work, about how to get interesting job and how to be happy, whatever. Do you have any questions regarding the approach?
Yeah, I do, Alexander. Thank you very much for the session. So what I actually wanted to ask is that, are there, or can you like maybe give to us some sample cases where semi-supervised learning might be very important? Of course, you already mentioned that when you have few labels and a lot of, few labeled data compared to a lot of unlabeled data. So like, apart from this demo you just showed us, which is really nice, are there been other cases maybe you've had to use semi-supervised learning to work around this, or like maybe some other, let me just say other use cases that one can find himself?
Okay, sounds great. Okay, great question. One use case that I can talk about, it's more complicated modeling, etc., but idea is certainly the same. I mentioned about this in the beginning. My previous job, oil and gas, Petronas, were one of the challenges that we had is corrosion detection. So what is the main problem? The main problem, huge oil and gas company, very well known, has a lot of different factories, refineries, and other things. So inside this refinery factory, there are a lot of constructions. These constructions become from time to time corroded, which is obviously dangerous. And if we don't spot this, to fix it will be much more expensive than to prevent it when we see it in like early stage. So the challenge that again we had is to have I don't know, some drone, whatever, and send it to fly, and after that, based on these photos and based on location, to send to engineers information. Okay, look, exactly here we see corrosion, and this is the photo, and this is the corrosion. But the challenge is, again, to create labeled data to build object detection model is super complicated and super expensive. So why not to try collect these all images and like label only few of them? not few, like 100, 200 maximum, like let's say, and after that apply this idea. So that's for you one use case. I didn't talk with my ex-colleagues before, but before I quit, we discussed about this idea. I don't know if they applied this or not, and in fact, they cannot even share with me because of non-disclosure agreement, but in my mind, it's absolutely clear use case. Second idea that can be applied, I don't know, maybe some companies apply it as well, like again, malware detection. What is the main challenge? The main challenge is when you have malicious software, as usual, these malicious actors try to create super obfuscated code, application, whatever. And for reverse engineers, it requires a lot of time to actually go through line by line and explore, is there some problems or not? Is this application trying to steal information? So we can try to have, I don't know, like 100 labeled examples, and other things just use kind of similarities in the input data. Does it make sense? Did I answer on your question?
Yes, very much, actually. Thank you. Thank you so much. So you mentioned that, I'm sorry, just one more question also. You mentioned that you use PyTorch. I mean, from this workflow, it's clear that they'll use PyTorch. So for example, let's say with TensorFlow, I don't know if you've worked so much with TensorFlow, but you already said also that the approach is similar in trying to create the encoder, the encoder and everything. With TensorFlow, how easy do you think it should be? It looks very straightforward to an extent with the work that you've done with PyTorch. So if someone is going to maybe try to implement semi-supervised in TensorFlow, do you think it might be much more complicated with PyTorch?
Okay, nice question. I'm super subjective because since I work at Meta, like Facebook, like ex-Facebook, whatever, created PyTorch together with NYU. TensorFlow was created by Google and I don't remember honestly which university in collaboration. Then idea is pretty straightforward. So majority of people working in Facebook, they try to use like PyTorch. As I know, my majority of people in Google use TensorFlow. People who don't work in this company prefer either of them or JAX, or before it was Keras. I don't know if it still exists. But the idea, again, pretty similar. So you have layers, you know these layers, like convolutional layer, fully connected layer, whatever, many other layers, and you just stack them together. That's your model. You just should be confident what is the output. So it's just same idea, just the question what you prefer, like PyTorch, TensorFlow, Keras, JAX, whatever. I don't see any significant difference. Before, I liked a bit more PyTorch, but compared with TensorFlow. But as I know now, it's much more close to each other than before, than TensorFlow 1. Like this. Did I answer on your question?
Yes, very much. Mm-hmm. Thank you so much for acknowledging that. Okay, I think one person Favor has a question. You can go ahead, Favor.
Hello. Okay. You made mention. Can you hear me, please?
Yes, I can hear you.
Okay. You made mention of both labeled data and unlabeled data used in supervised, semi-supervised learning. Can you tell me if it's only
sorry, you disappeared in the end. It's only for me?
No, it's not. Favor, can you go again?
No, it's not.
Favor, can you go again?
Okay. Okay, like, do you always need an equal amount of labeled data and unlabeled data in semi-supervised learning, or it depends on the situation, or is there any is there a factor that we measure of labeled data and unlabeled data we need to have? You get it, right?
You disappeared in the middle again. You said that I have labeled data, I have unlabeled data, and after that I didn't hear you.
Yeah, I said, is it always necessary to have equal amount of both types, or it varies?
No. Great question. In fact, no. In fact, as in reality, we have small amount of labeled data and huge amount of unlabeled data. No, it's not necessary to have same amount. In fact, you can use small amount of labeled data just for some guidance and large amount of unlabeled data to extract dependencies inside the data.
All right, thank you so much.
Okay.
Thank you, Fibo, for that question. So I don't think there's any more questions. So I think you can go ahead.
Then.
Okay, sorry.
Okay, sure.
I think there's okay, that will come. You can go ahead now. You can go ahead now.
What is the question?
No, it's not. The person dropped their hand, so I think.
Okay. Then sure. Then let me share again another my screen, and we can try to chat about more general topic. Okay. If you have some questions, you can ask them, but I will start from my initial thoughts, questions that I asked before. First of all,
Hi, I have a question.
Hello. Yeah.
So, coming from somebody that is new into tech, that is transitioning into tech, what is like how do I get started into getting machine learning? What is like the first step for me to become vast in this field, just like you?
Okay, great question. Then can I answer on this question a bit later, because I wanted to give some background that itself this information might already answer on this question.
Okay, thank you.
Yeah, and we will come back if it does not. So I mentioned in the beginning that when I studied in school, I loved mathematics. I participated in some school Olympiads. I assume like any country has something like this. And in fact, that time I even didn't know word like machine learning, data science, whatever. I just enjoyed what I was doing. I was born in a small city in a super poor family that time. I cannot say that I didn't have food. I had food, but that's it what I had that time. And I just enjoyed my life. I enjoyed solving mathematics. Sometimes nobody asked me about this, but I just sit and calculate something, try to find solution, and had fun about this. And later, I found a job in finance where I calculated probability that this particular guy will return money, will not return money. And in fact, we did not call it machine learning. We called it credit risks, etc. Only later we found out that there is a fancy word, machine learning. So coming back to your question, I would answer on the question of why do you want to go to machine learning? Because you like something related to this, I don't know, calculate numbers, solve competitive tasks, or because it's hype word, because it's pretty popular job, etc. That's super important question in my mind. So what is your goal? Like, why you want to go to machine learning?
Okay. I was doing a research and I was checking the numbers and the statistics. I wanted a field in tech that is not too populated, and according to my research and the numbers, I saw that machine learning is actually, should I say, underestimated. We don't have a lot of people in it, unlike, the other software engineering and the likes. And I just thought that, why can't I try this out? But talking about numbers, somebody that does not like mathematics, is it possible for the person to thrive in that aspect?
Okay. I don't know. Do you know this guy, Andrei Karpathy? Is pretty famous researcher in artificial intelligence. He worked in Tesla as a director. Now he works in OpenAI, and he answered on similar question. He said that the best way to get into some field or to become expert in this is just simply doing something like many hours, 10,000 hours. He just mentioned like 10,000 hours, just repeat, do mistakes, etc. But why I asked, I partly agree with this statement. Why I asked, like, what do you want? Because in my mind, if you like what you are doing, you easily will spend this amount of hours, like doing mistakes, enjoying, etc. But if you just found some popular, some hype field like machine learning, and start exploring something, start like trying tasks, etc., then you will become bored, you will hate all world, etc. So that's as important. But like shortly answering on your question, like let's say you decided, okay, I like it, I want to explore, I want to do something. Then many people will tell, okay, try to explore some theory, but try to do it as soon as possible. And after that, try to solve many tasks. And after that, try to approach people who already work in some companies that you like, just with the question like, hi, Alex, I'm curious about this. Could you please help me to find out, I don't know, how to solve this problem, or I have this idea, or how can I get to this company? Can you refer me, whatever. So some theory, after that as many as possible practice, and talk with people who already work. That's the answer. Does it make sense?
Yeah, it does for now. So you can go on until I have another question.
Okay, cool. I just wrote here research versus engineering, day-to-day activities, the most important skills. I will start, if you don't mind, from the most important skills in my mind, because it's somehow related to what you asked. Many people, I heard like many times from different people, okay, now, I don't know, NLP became super famous, demand is changing, or like ChatGPT became super powerful, now majority of engineers will lose job, etc. So we need to switch to some specific skill set. In my mind, it is true, but only partly true, because coming back again to my point about love, like, do you like what you're doing or not? If you are curious, if you continue exploring what is the approaches, etc., you will still be super valuable. So just shortly, like what is in my mind the most important skill set is not some like knowledge even of like PyTorch or TensorFlow. It's critical thinking, always asking questions. Like, I don't know, it's me or it's your manager, whatever, tell you, you need to do this one, like this is right. If you're always asking questions like, is it true? Or maybe there is a problem here. What if I explore? Not like not believing anyone who will tell you like how to do. Always asking yourself, maybe there is mistake here. Maybe I can explore more. It's like first like critical thinking. Second, always like desire to become better. You reached some level. I don't know. You became machine learning engineer. You worked 2 years there, and you already, oh wow, cool! I am like better than my classmates. No, that's not enough. You need to continue learning. You need to continue improving yourself, etc. Curiosity, it's pretty close. And I didn't mention one important thing. I know many people who are super smart, many people who can tell me about my mistakes, like I did something wrong, you are wrong, etc. But not many people are able to start the task and finish it, like bring to the end, get result and implement it. So ability to finish it, just another important skill. Does this make sense? Because again, if I talk about some specific things like, okay, learn TensorFlow and you will get the job. Partly yes, but later people might not like TensorFlow anymore and start using another thing, and like TensorFlow will not be cool anymore. But if you are able to learn, that's great. So I see that Miriam and Precious wanted to ask questions. Do you have them still?
Yes. Thank you very much, Alexander. So I'll just ask a few questions of my own too. I think everyone will be able to benefit from. So I'd like to say, I mean, you already shared that you have so much interest in mathematics, and that's how you kind of got started. So, but I just want to have maybe more details. Was it like maybe from, I mean, here, secondary school, high school, or in the university that you got started with machine learning, and then let me see, you already talked on skills also, right? But like, what would you say were the things that you knew at the points you got your first job, right? That you feel kind of made you get that job, that made you stand out to get that job. So how you got started, and what particular skills you feel made you stand out to get your first job in machine learning?
In fact, it wasn't that straightforward and it wasn't easy. I did a lot of mistakes. More precisely, like I studied in my school, I loved mathematics, but I had no idea like why I need mathematics, why I need to do it, and where I'm going to use it. In the beginning, I literally applied to any job that I could find. And that was a huge mistake in my mind because I didn't focus on my strengths. I just didn't listen the time some of my mentors who told me, Alex, just focus on particular thing. Like maybe you will get job a bit later, but just focus, become better and focus on job related to modeling that you can do. I didn't do it. I looked for like any job, and I spent a few years working in the companies where I struggled, where I in the beginning was like the same as other people. I didn't like my job. Before I realized that, okay, cool, I don't want to live anymore this life. I need to stop. I need to sit and prepare specifically for for credit risks, for machine learning, etc. And I just stopped. I learned more. I built some practical algorithms. I approached my friends who worked in machine learning and asked them, can I build for you some models that you need, and I don't need even money? So that's what I did, like focused on specific field. Did I answer on your question?
Yes, you did. You did actually. And also one more thing for the person that raised their hand, like you said for you tried different things. So
So sorry, you disappeared in the end. I tried different things, and after that, what? Could you repeat, please?
so sorry, I lost connection there. I don't know if you can hear me now.
It's okay. Now I can hear you.
Yeah. So I wanted to, okay. So I wanted to say, like, for your first job now, what skills or what things did you have at that point? Maybe what kind of projects have you worked on that maybe were interest that you found really interesting or something?
You are talking about my first job not related to machine learning, or my first job related to machine learning?
No, so your first job related to machine learning.
Finance. It was finance. It was credit scoring. So I tried to help my friend who already worked in the bank to experiment with different modeling. That time it was simple logistic regression, and the idea was how the best way to prepare data to avoid overfitting that time.
Oh, okay. Thank you very much for that. So what you're trying to say is that you did. Okay. Yeah. Go
Continue.
ahead.
Continue.
Okay, so what I wanted to ask was like, so from what you shared now, it doesn't necessarily mean that you have to have maybe very advanced AI skills, like maybe say GANs, right, generative adversarial networks or stuff like that, like kind of heavy projects. Okay.
No, not at all. Sometimes, actually, majority of the time, people don't have time to look at some simple details that does not require super technical knowledge. Sometimes, not even sometimes, many engineers focus on technical approach. Technical approach is good when you already understand background very well and try simple things. Like try simple things, see result, and in majority of cases you will see that you improve algorithms very well. It's not academia. In the companies, people not always have time just even to apply simple logistic regression.
Oh, okay. That's I'm just hearing that for the first time. So thank you very much for sharing that. I think
I cannot mention sorry company, but one of my companies pretty famous. Couple of times I just take some working model, look at this, and I just realized that people did not apply pretty basic things. And it does not show that they are bad. It shows that people don't have time. And you can just take some working model, explore it, and make it better just looking at this in some more details.
That's actually very true. All right. So more of reviewing and then improving on existing simple approaches. Okay, thank you. So Monsurat, I think you can go ahead and ask your question.
Okay. Hi. Good evening, everyone. So my question is actually two. So the first one is I have the skill to succeed as a machine learning engineer. I've actually done internship with a machine learning research company, and it was a successful internship and all. But I transitioned from microbiology into machine learning, and I noticed that most companies want people from mathematics, computer, machine learning background. Can you hear me?
I can hear you, and I start smiling because microbiology is something I cannot say that it's exactly my dream, but it's something in my mind super cool. Because
Yeah.
now people try to merge and mix machine learning approach and knowledge of microbiology, medicine, and something like this.
Yeah. So I noticed that because I actually even check companies like what's this company name? Actually I don't know why I forgot this now. So even though they deal with they have like biology aspects in their company, they also want people from machine learning background. They don't want people from biology background to work as a machine learning engineer for them. So, and this has made me to like start looking from schools that I can do my master's in machine learning. But and I found out that these schools also want people from computer mathematics background. So I'm like kind of I don't know how to like go about it because I'm in the loop. I want to go to school. They don't want my background in microbiology, and I'm looking for a job. They don't want my background in microbiology. They want mathematics, and I really want to work as a machine learning engineer. How do I do this?
Okay, great question. I have. Okay, I will answer first, and you will correct me if I didn't understand fully your question. I didn't understand some background. Okay, so
Okay.
Sometimes when you say some company, some university ask you specific background, I don't know, 3 years working experience with machine learning, I don't know, some specific university, etc. Based on my experience, it is true, but only partially true. When we are talking about companies that don't have experienced machine learning engineers, they definitely ask exactly what you described. But if we are talking about more advanced companies, more advanced startups, they don't ask you exact amount of years or exact name of your previous role. They ask from you some knowledge and curiosity. So exactly, you approach and say, like, guys, I'm interested in this. Can I learn from you? Can I try to explore something? The key thing here, you are interested. Like when you say mathematics, the question that I have, do you understand mathematics? Do you understand, I don't know, what is linear algebra? If you read this and you understand this, but it's complicated for you, everything is great. But if you don't, if you cannot calculate matrices, that can be more complicated.
Okay.
Did I answer on your question?
Yes, you do, but yes, you did. But I also have like even I know that you said some companies don't ask, but most companies, I don't know if I'm the one that is seeing those companies because in their job description they're like bachelor or masters in machine learning, computer or mathematics or related background. So I'm not sure if I'm looking, maybe there are some stuff that I'm supposed to be looking at that I'm not looking at, maybe keywords or something that I can incorporate also.
Understand. If you want, text me after that and we can chat in more details. You can share with me like more
Okay.
details, what you were looking for and etc. And in fact, when you say like specific masters, etc., I had one topic that I wanted a bit to share between research and engineering. When you work at Meta, at Google, whatever, these companies, you can sometimes change teams. And when you change teams, it's kind of external hiring. Some teams in research, they specifically ask publication in this conference, but some teams don't ask. They just want to see, can you do job well or not? Depends.
Yeah.
Sometimes you're absolutely right, but you're definitely able to find company which does not ask from you specific experience. They ask from you knowledge and curiosity. If you really can do it, if you can learn in internet, then you definitely able to find company that will not ask from you specific experience.
Okay. Thank you so much for that. And I will definitely message you after the call.
Sure.
All right. Thank you very much, Aleksandr. If there are any more questions, you can kindly raise your hand. So just while we wait for that, I just want to ask one last question from my end. So I'd like to know what things, you already mentioned, you briefed on this as regards, if you're going to be specific on particular skills. AI is changing so much, and maybe in a couple of years, the skill you mentioned the person should learn might not be so relevant at that particular time in the future. But how can you recommend one to upskill with the way ML is changing, or let me say, advancing at a very fast rate? So in terms of large language models currently, to to have enough, you have to have skills that are still relevant even in coming years. So like how do you upskill, or how can you recommend one to upskill in such a way that you remain relevant in the market, whether whatever solution you want to build or working with an organization, you remain relevant based on the skills that you still have or you have newly learned or newly acquired. How can you recommend one to upskill with the fast changes in machine learning as a whole?
Okay.
Yeah.
Okay. There are two parts of this question. First of all, in this like fast-paced changing environment, it is changing fast. It is changing fast in research, but in the companies, in fact, it's not changing too fast. I don't know. I worked in Malaysia, and people are still looking for knowledge in Python, knowledge in Pandas, NumPy, whatever. PyTorch is still in the top, etc. That's why I would just learn, and the most important, use the most famous tools, like, I don't know, PyTorch, language, Python, whatever. But what is much more important, and I will highlight it again, is your curiosity, is your desire to learn. You can follow few the most important researchers, professors, whatever. I don't know, Jan LeCun, the guy who is vice president of like chief researchers in Meta. Andrew NG, who is always talking about some news, etc., etc. So you just see some updates, you see some cool article, you take this article and read it. You don't need to read too much. Like, I don't know, one article a week is the best. You will become in 2 years maximum super experienced machine learning engineer. If you read one article a month, it's already great, etc. Just follow the most famous researchers, better researchers, like, I don't know, professors, whatever, than someone, I don't know, someone without this background, and you will be absolutely great. So don't stress yourself about super fast changing field, and that's it. Remember that it's changing, but in fact, you are good with this if you follow news and try to implement something.
Okay.
Does it make sense?
It makes a whole lot of sense. A whole lot of sense, actually. Thank you very much for sharing this.
Yeah.
And then I don't think there are any more questions from anyone. So thank you very much, Aleksandr, and to everyone that's taken out time to join. I think I would appreciate
thank you so much.
I'd appreciate you can share your slides in the chat and maybe the notebook, so we can
sure.
yeah,
I will. I can share it with you, and you can. Yeah, sure. And
right.
I just left in the chat my email, but it will be anyway in on the slides.
Okay. Thank you very much, Aleksandr. Thank you to everyone that's made our time to join in. If you still have any questions, maybe, he's dropped his email already, so probably you can access him through his email or LinkedIn. I don't know if you respond very well on LinkedIn, but you can chat him up through LinkedIn and through his email address that he has dropped. I'm very grateful,
yeah, sure.
Aleksandr, that you've made our time for us. And I believe everyone has learned many things. I'm not going to say a few. I think I personally have learned many things from this call or this meeting, and super grateful. I believe many others too are. So that will be all for today. Enjoy the rest of your day, and I'll keep in touch as regards the recording for those that might be interested in that, and the slides and notebook from Aleksandr. That's all. Bye.
Thank you so much again. Bye-bye. Yeah. Thank you.